Hello to everyone. I am Professor Raja, working as Assistant Professor, ECE Department, SNS College of Technology, an autonomous institution, Coimbatore. In this YouTube video, I am going to discuss about 23 ECET 221 Microprocessors and Microcontroller subject under Unit 2, the topic 8085 Memory and Input-Output Interfacing. Already, our students will know about what is meant by microprocessor and how this microprocessor is different from microcontroller and how these two are used in real-time application that we are already discussed in case study and DT based application. Now we are going to discuss about 8085 memory and input-output interfacing. Let us move on to the topic. Memory interfacing is the 8085 microprocessor involves connecting external memory chips like RAM and ROM to the processor to expand its storage capabilities. This allows the 8085 to access and utilize more data and instructions for executing more complex programs. This process involves address decoding using control signals like read and write to enable read and write operations and connecting the memory's data bus to the processor data bus. Next, to understand this concept, let us move on to the individual topic. The step 1, understanding the 8085 memory addressing. In general, this 8085 has 16 address lines, that is starting from A0 to A15, and it allows to address 2 power 16, that is 64 kilobyte of memory. This address space can be divided between RAM, that is random access memory, ROM, read-only memory, and input-output devices. Next, we will see the important terms of key components in memory interfacing. Whenever we are going to interface the external memory to the 8085 microprocessor, we need to consider the 4 important parameters. One is the memory chips, second one is the address decoder, third one is the control signal, fourth one is the data bus. Memory chips means already we know in 8085 they are using 2 kind of memory chips. One is RAM, another one is ROM that store data and instruction. Next, address decoder. This address decoder translates the 8085 address signals into chip select signals that enabling the selection of specific memory chips. In famous, 8085 consists of 2 control signals, that is RD and WR. These signals are generated by 8085 that controls the read and write operations of the memory chips. Next and last one is the data bus. The 8085 consists of bidirectional data bus that connects the memory chips to the 8085 for data transfer. The third important step is memory interfacing. First, we have to determine the memory requirements. First, we have to decide the amount of RAM and ROM that is needed for the application. So, depend upon the application, the RAM and ROM size may be increased. Next is the address allocation. We can assign specific memory ranges to RAM, ROM and input-output devices within the 64 kilobyte of address space. Next is the address decoding. Design an address decoder circuit, that is by using logic gates or some external encoder circuit like 74LS138. We have to generate a chip select signals for individual memory chips based on the address lines. Next is the connecting data bus. Connect the data bus of the memory chips to the 8085 data bus, that is D0 to D7. Generating control signals. As I told earlier, microprocessor is very famous to perform read, write and connecting input and memory interfaces. So connect the 8085 control signals to the memory chip control signals like output enable or write enable through appropriate logic gates or buffers. The last stage is the testing stage. We need to verify a proper functioning of the memory interface by checking data read and write operations. The memory is made up of semiconductor material used to store the programs and data. In general, 8085 consists of more number of storage registers, that is the accumulator, special function registers called BCDEHL, and sometimes they are used as stack pointer or sometimes program counter for additional need of data storage. And this all the above said data structures are comes under 3 types of memory. One is called processor memory, second one is called primary or main memory, the third is the external memory or secondary memory. Next, we can individually see what is typical EEPROM and static RAM. A typical semiconductor IC will have n type of address pins and m type of data pins. That is n number of address pins, m number of data pins. The data pins also called output pins. It have two power supply pins, one for connecting required supply voltage and another for connecting ground voltage supply. The control signals needed for static RAM are chip select, read control and write control. These control signals needed for read operation in EEPROM are chip select and read control. Next we can see the important topic of applications of microprocessor. The main applications of microprocessor are used in mobile phones, digital watches, washing machine, computer, lighting control, traffic control, laptop for processing applications, modem for connecting receiver and transmitter, power stations for delivering a proper power, television and CD player. So I hope in this YouTube video you will understand what is the meaning of memory interfacing and how much number of signals that are performed by 8085 microprocessor and the very important applications of microprocessor are discussed. Next YouTube video I will bring a new innovative topic for discussion. Thank you for watching my video. Thank you.